Hello, I'm Arjun from SciKids, and today I'll be talking about cohesion and adhesion. So two properties of water that are very important for sustaining life on Earth are cohesion and adhesion. Cohesion is the ability of water molecules to stick to itself, and adhesion is the ability of water to stick to other molecules or surfaces. So as we know, a water molecule is made up of one oxygen atom and two hydrogen atoms. Cohesion happens due to the formation of hydrogen bonds between the one slightly electronegative oxygen atom of one water molecule and the slightly positive charged hydrogen atoms of another water molecule. So to visualize this a bit better, let's place drops of water onto this penny wax paper and then this paper towel. So first the penny. So as you can see, instead of breaking or spilling, it forms in this little droplet and it just stays on the penny. So now let's try it on the wax paper with this blue food coloring with water. So as you can see here, instead of spreading around like it would on normal paper or any other surface, it sticks and it just attaches to the surface in these little droplets. So this is due to cohesion, where the water molecules hold on to themselves. However, if you place the water on this paper towel, you'll see that it starts to spread out and doesn't stay in any droplets whatsoever. So this is due to the adhesion between the water and the paper. The adhesive force between the water and the paper towel is stronger than the cohesive forces between the water molecules themselves. This results in the water spreading out as the ability of water to stick to a surface depends on the nature of the surface. So now let's do an experiment to explore this further.
So in order to do this experiment, first we'll need 3 little plastic cups. Then we need some food color. It needs to be 2 different colors as well. And then some paper towels. And a spoon in order to mix it with. So first what we'll do is we'll fill up the cups on both ends with water to about this much, and then this one as well. And now we'll add some food coloring to either side. And so basically what this does is this allows for better visibility to see how the water transfers, and this just basically helps you see it better, although it's not completely necessary. So we just drop it in and then we'll use the spoon to mix it. And so now we take these 2 sheets of paper towels and we just fold it in half, and now we just roll it up. And then we'll cut off like the little ends of this just so that it's a good amount and so that it's not too long to fit in both cups. And then we can just make sure that the tips are in both of these cups. And now we'll do the same with another paper towel. And we just cut off the end of this one as well. And so, as you can see, all of the water is transferred to the middle, and there's an equal amount of water in each cup now.
Now, let's examine the science behind this. You must have noticed that in this experiment, the water is moving up against gravity through the paper towel. This happens due to cohesion, the force of attraction between molecules of the same substance, as well as adhesion, which is the force of attraction between different substances. As we discussed before, the water molecules are all bound to each other by cohesion. As one water molecule is pulled up, the rest of the water molecules are also going to move up. Here, we used a paper towel to move the water. These paper towels are made of cellulose materials, and the small spaces between the cellulose molecules make these towels very absorbent. When the paper towel is in contact with water, due to the force of adhesion, the water molecules are attracted to the fibers of the paper towel. The water molecules are thus able to move upwards through the material. The combination of these two attractive forces is enough to draw up the water against the force of gravity and move the water from one cup to another. Once the levels of water became equal in all three cups, the water stops flowing. What we saw here is water being transferred from one container to another by capillary action. Now, what do you think of the role of capillary action in our daily lives? To explore this, let's do one more experiment where we look at the real-life applications of capillary action.
So to begin, we'll need 3 plastic cups. And we need, so we use 2 different colors, or even just 1 or 3 colors works as well for this.
In order to do this experiment, first let's set the 3 cups side by side and fill them with water. Then we'll add around 10 drops of food coloring to this water, and we used red and glue as it's the best for using green plants. So after adding the food coloring, we'll set a white flower, a celery stick, and romaine lettuce into each of the cups. Before placing the celery stalk in the cup though, make sure that you have enough to cut the bottom of the stalk before placing it into the water, and we'll explain why shortly. Now we'll leave this here for a few hours. So after about 24 hours, we'll take a look at the plants. So before, this is the celery this is just a regular celery stick with nothing done to it. So as you can see, these little vessels are there's no coloring to them. You can see those little dots there? They have no coloring and they're just white or green. So these are called the xylem vessels, and that's where the water gets transported up the plant. So now, let's look at the celery stick, which was placed in water. So as you can see, the red food coloring got all around it, and so as we cut the base off, you'll see that the little xylem vessels have turned red now. So that's because that's where the water goes up through the plant, and that's where the water has that's where the water has stained, as that's where it goes up. And that's because the water only goes through these vascular tissues and not anywhere else on the stalk. So now let's look at this romaine lettuce leaf in addition. So as you can see here, the xylem vessels are also colored red. And so this is how a cross section looks. If you leave the leaf in the water for longer, you'll be able to see color all over the leaf. So now, if we cut a bit more up to where it's not completely stained by the red, we can see that the xylem vessels the little dots are also red. So now, finally, let's look at the white flower that we placed in the blue water. So, as you can see, the water traveled up and the flower, which was pure white before, began getting blue coloration. And the amount of coloration increases the longer that we leave it in the water.
So, what's the science behind this? The water that the plants absorb through the roots moves all the way up to the plant through the xylem via capillary action. Just as the water molecule stuck to the fibers of the paper towel in the previous experiment, the water molecules can stick to the walls of the xylem via adhesion. Additionally, the water molecules can stick to themselves via cohesion, and using both these properties, it's able to move its way up the plant. Once the water travels all the way up to the leaves, it evaporates through a process called transpiration. As transpiration happens, more water will move up the plant via capillary action, which helps to maintain this cycle. Thank you so much for watching.